Hello, everyone. Good morning, good afternoon, good evening from wherever you're joining us. My name is Dalia, and I work on the developer marketing team here at Kong. I'm very happy to welcome you all to our November user call. The topic for today is WebAssembly in Kong using WasmX. We got a lot of questions for this topic for quite some time now, so I'm very happy to have Hisham here, who will walk you through this very interesting topic. Please post all of your questions in the Q&A function on the bottom, and we will answer them at the end. And with that, I would like to pass it on to Hisham.
Thanks, Dalia. Yeah, happy to be here. And hi, everyone. I'm Hisham, and I've been at Kong since 2017, working on the Gateway team, and now I'm involved with the WasmX project. So I'm excited to tell you all about it. This is the next cool thing that we're developing here at Kong. And so this is a presentation that I gave at Kong Summit 2022. We've got lots of great feedback around it. So yeah, so Dalia invited me to join the user call and talk to you folks about it. So yeah, let's get started. You all can see my screen. So yeah, so for this one, we're going to be starting like from the very beginning to make sure everyone's on the same page. We'll start with a recap of what is WebAssembly, because there's a lot of hype around it. There's a lot of people talking about it, and like it's almost always in the context of web browsers and such. So like, what is it doing, and the gateway, what does it have to do with Kong? So I hope to make that connection clearer. So, and then we'll proceed with what is WasmX. So, all right, so like what is the connection and how are we approaching WebAssembly in the context of Kong? And that will be leveraging something called Proxy-Wasm, which I will tell you folks about it as well and explain what it is. And we'll get to how it all fits together in the Kong gateway. And finally, with a very quick demo of our tech preview that's upcoming. So that's a little spoiler for you to hold you here to the end of the presentation. So let's go bit by bit. So let's start with the beginning, WebAssembly, okay, the first part. That is the virtual machine that we'll be using. So first, super quick primer on virtual machines. So what are they, like? They allow us to make for extensible software. So we have a program, in the case the gateway, and we run little programs inside of the program, right? So this is what happens in the web browser, which is also an extensible piece of software in which we run JavaScript, those scripts. And in the context of the gateway, we already have that. So where in browsers you have JavaScript, in the gateway we currently have Lua. And then there's a distinction between the language and its implementation, which is something that's interesting to keep in mind. So for different web browsers, we have different JavaScript VMs, right? V8 in Chrome, JS Core in Safari, SpiderMonkey in Firefox, and so on. So for the Kong gateway, the implementation of the Lua language that we use for running plugins is LuaJIT. So that LuaJIT is our VM for running Lua inside the gateway. Right, and the extensibility that we get from that is like all of the plugins that we know and love. But soon enough, people tend to find that a single scripting language is often not enough, and when you start to want to expand the scope of what you can do with a piece of software, like other avenues for extensibility start to come up. So in the context of web browsers, like as the limitations of JavaScript became evident, right, people started doing like other add-ons, like remember Flash and all of that, remember Java applets, like they become like rather unwieldy ways of like, trying to connect like additional VMs into the environment. So for the gateway, we went to a similar path at one point in time, right? In which we started experimenting with the idea of adding like additional PDKs where we would run like a plugin server that would add a VM as a sidecar. So in the end, it felt kind of clunky. It felt like very similar to the way that Java applets were sort of bolted on into the web browser. And yeah, and at first the result was not ideal, like as it was not ideal for the browser, right? So it was a very similar experience. So enter WebAssembly. right? So just like when the browser folks realized that way of doing things, that way of extending it, like with Flash and Java, like that didn't work as well as it should. So they came up with WebAssembly, which we also call WasM, right? It really appeared as like it came along as an alternative to JavaScript, right? So in that sense, we want to have in the browser like a virtual machine that's generic, that's not tied to a single language, right? So something that supports multiple languages, and the way, since that needed an interoperability across browsers, that has been developed as an open standard. So WebAssembly itself, what it does, it defines a binary code format, right? Like in Java parlance, that would be like a bytecode format, and a specification of a virtual machine. So this is like that. You need to have like this library that appears as a virtual machine that's able to run this binary code format. And no matter how you compile and you get to that binary code format, that means like whatever language you're using, as long as you build to that binary format, then you should be able to run that on that virtual machine. And then any application, like any browser originally, that it's able to embed that virtual machine will be able to run that binary format. So that means that you can have several implementations. And in fact, like many of those JavaScript VMs, they were extended to become WebAssembly VMs, right? So because you can pretty much reuse like all of the backend, and then instead of a front end that's designed for compiling JavaScript, instead you make a front end that consumes this binary format, and then you use an external compiler from your favorite language to build to that format, which would be like a .wasm file, and that file could then run in the virtual machine. So that's how the whole WebAssembly story started in the context of a browser. So, well, so if things, as soon as things were built that way, like it became possible for it to use it in other contexts as well. So that's what we're doing here. So why WebAssembly in the context of Kong? Well, because just like browsers used it as an alternative to JavaScript, we can use it as an alternative to Lua, and then we get like a lot of the advantages that became apparent for the browser, they can apply for us as well, right? Starting with supporting multiple languages, we can leverage several different implementations as opposed to being tied to a single implementation of a virtual machine. And plus, then we have additional advantage is that in that, for instance, WebAssembly virtual machines were designed from the get-go with very powerful sandboxing capabilities. After all, they need to run in browsers, right? And since it's based on this abstracted like binary format in which like any language can, as long as it builds to it, it can run. It means that we don't need to implement multiple PDKs, like multiple plugin development kits, and do the whole integration of a language one by one. As soon as we support WebAssembly and we have the integration of our functionality with WebAssembly, then that becomes available for every supported language. So that's a very interesting proposition. And that's why we started looking at WebAssembly in the context of Kong, in the context of the gateway, right? So, all right. So now that we're convinced that WebAssembly is a good idea for the gateway, okay, how do we go about it, right? So now we need to start talking about the architecture of the gateway to understand how do virtual machines fit in that scenario, and how would we go about to integrating WebAssembly virtual machine into that, right? So enter WasmX. So to get to WasmX, we need to start understanding the architecture first. And the architecture of Kong is that it is built on top of Nginx, and Nginx itself is built as a series of modules, right? You can think of them as the Lego bricks of your server, right? And an Nginx binary, which is the things that your Kong container is ultimately running, it's built from several modules, right? And you can build Nginx by mixing and matching them, right? So you have like the HTTP core module, the stream module, which is the one that runs like raw TCP connections, and then several other modules for things like SSL support, gRPC, compression, and so on. And one particular module which is very interesting is the OpenResty module, which is an Nginx module which embeds the legit virtual machine. So this is essentially what OpenResty is. So when we think of an abstracted view of the architecture, we think about, we often say that, oh, we have Nginx with OpenResty running on top, and then Kong is built on top of that. So this is a bit more of a detailed view of how things are constructed. So when we get to that point where, okay, so what is WasmX? Well, it's another one of those Lego bricks, right? It's an Nginx module that, just like OpenResty, embeds the legit virtual machine. WasmX is an Nginx module that can embed a WebAssembly virtual machine, right? This module is developed by Kong. It runs a Wasm VM inside Nginx, and it supports multiple VMs, right? We have done the integration work for supporting different VMs. So at compilation time, you can we can choose which VM will run in there. So currently we support Wasm Time, Wasmer, and V8, which is the virtual machine used in Google Chrome. So there are two parts to this, which is, one is that the task of embedding the VM inside Nginx and having it run that. But then, like, a VM running alone, like isolated in its little world, is of no use. The whole point of the integration is to connect Nginx functionality into Wasm code. So exposing interfaces so that the Wasm that runs in there, like those .wasm files that were compiled in like your language of choice and loaded into the VM, they can actually interact with the other Nginx modules and do useful things. So how WasmX fits into the picture? Essentially, it is compiled into the Nginx binary, and inside it, you will have a Wasm VM, which is compiled as a library, loaded into the WasmX module, and ultimately in the Nginx binary that will be running itself. And as a bit of foreshadowing, yes, you can run both at the same time and get an Nginx binary which has the OpenResty module loaded in and a WasmX module, and having both VMs running at the same time. That's the nature, that's the modular nature of Nginx coming into play. So as I told you, the first half of the story for WasmX really is the integration with the VM. But just as important is that bit about how it connects to gateway functionality, right? How you can actually do network-oriented things with it and get those APIs available for you. So the API that is exposed for the Wasm code to actually do useful things when running inside WasmX is called Proxy-Wasm. So that's the bit that we will be looking at next. And so it's always useful to start thinking about, like, what is an API anyway, right? Because so in a sense, the API is the developer's user interface, right? Is, okay, what do I have available in order to do things, right? If you're thinking about like a graphical program, okay, your interface is like the places that you can click, the buttons that you have, like, so where you can like poke the application in order to make it do things. So when you think about an extensibility platform, the way that WasmX is, in which, okay, I can write code and load that code in, and that code instead, like, and on its turn, will poke the application and do things. So essentially, like, the way it does that is through the API. And so in that sense, the API is the user interface. And when we think about that user interface in current Kong, right? One thing that we always try to make a point of is that, like, Kong users shouldn't have to deal with those Nginx like Lego bricks directly, right? So so even though Kong runs on top of Nginx, like, you can access that if you want to, but you don't have to in order to be productive. Like, you don't have to like look at it as an Nginx instance. Like, you can look at it and see a Kong instance which has like its own Kong configuration, which does everything that it needs, right? And at the same time, You don't have to go deep into OpenResty in order to be effective using Kong, but you can still just look at it and see like, okay, these are like Kong Lua plugins, right? So, and you don't have to deal with OpenResty callbacks directly. You can use the Kong APIs. So, and at the same time, OpenResty exposes those like very lower level, like Nginx or REST called like REST APIs, like the REST namespace in the LuaJIT VM. But we also provide you a higher level, like the Kong plugin development kit, which offers like much higher level functions, which are defined in terms of the domain of an API gateway, right? And not just like a lower level like reverse proxy. So with that in mind, when we progress into the WebAssembly context, we will need to think, okay, so what will be exposed, what will be available for a programmer to use when developing a WebAssembly extension. So that is Proxy-Wasm. And just like WebAssembly is this agnostic, application agnostic, implementation agnostic definition of a virtual machine for running this file format, which is WebAssembly, Proxy-Wasm is a gateway agnostic API for proxy filters of different kinds. Right. So just like WebAssembly itself is a binary format, Proxy-Wasm is a language independent API, right? Here's a little difference from an API, an application programming interface. Here we're really talking about an application binary interface. So that like, as long as you have an implementation of the Proxy-Wasm SDK, which generates a WebAssembly module file, right? A little library that does the correct calls following that binary specification, then it will be compatible. So that way you can have SDKs which provide like very natural native looking interfaces for whatever language you're using, which all of them will generate code that's compatible with a Proxy-Wasm enabled host. So which WasmX is. So we have, there are all various third-party Proxy-Wasm SDKs implemented for different languages already, right? Such as for Rust, for Go, for C++, for AssemblyScript. AssemblyScript is pretty much a dialect of TypeScript, which is itself a dialect of JavaScript, which has like little changes so that it can be compiled efficiently into WebAssembly, right? So basically, if you know JavaScript, if you know TypeScript, then you pretty much know AssemblyScript. And Proxy-Wasm, so as such, is an evolving specification, so that as proxies get more and more sophisticated in how they use it, they will want like, okay, I need this extra function there, and so the standard itself is evolving, and as are most things in the WebAssembly space, right? Everything's very cutting edge at this point in time there, which is very exciting and an opportunity to help shape those standards. And most importantly, when we say gateway agnostic, we really mean it, because it's gateway independent. It was originally implemented for Envoy, and it's being implemented in WasmX. So essentially what you have is that once you write a WebAssembly module that implements a proxy filter, you following the Proxy-Wasm API, and which generates code that follows the Proxy-Wasm API, that means that you've built a module that can run as an Envoy filter and as a WasmX filter, right? One of them and like running on Envoy proxy, and the other one in Kong gateway. And this is a super exciting proposition. So I think at this point it becomes clear like why Proxy-Wasm, right? Because we didn't have to necessarily adopt this API, but there are several benefits in doing so, right? We can, at first, well, one is that, well, from our side as developers of WasmX, well, we implement the API once, right? We make all of the necessary hooks so that WebAssembly modules can access those function signatures, and then out of the box we get support for all of those different language SDKs, which is very different from how it was for the plugin server PDKs that we were trying to do one by one for Kong. And the story for interoperability becomes very interesting because on one side we have Kong Gateway, which is based on Nginx technology, but on the other side we have Kong Mesh, which is built on Envoy technology. So the idea of being able to write filters, write extensions that could potentially in the future run in both is super interesting. And then again, as I said, like the idea of supporting an evolving industry standard and give our contributions to it is also very interesting. So we went with Proxy-Wasm as the programmer API for that, and we've done so by implementing the API into WasmX. So whenever you build WasmX, what it does is that it embeds WebAssembly virtual machine and then connects it to all of those Proxy-Wasm entry points to make any like Wasm module that you load into it support those entry points. So now that we have our new Lego brick that is WebAssembly enabled, right? We have to start thinking about how to get everything, all the pieces together, right? So then we get to the tech review. The tech review was originally announced at Kong Summit a couple of months ago, so it's still pretty new. And at the end of our presentation, I'll give you links so that you can get your own hands on it and play with it. So, but first, I would like to explain to you, okay, how are these pieces connected together? How do we get it to run in the gateway? So let's get back to that diagram of the architecture of Kong and expand that a little bit. So how it all currently fits together, right? What we really have is we have that Nginx binary built of several modules. We have that OpenResty module that loads a LuaJIT VM. And inside the namespace of that VM, that's where you have all of the Lua code running. So if I blow up the view of what's running like inside that LuaJIT VM, so I'm painting everything that's like Lua blue here in the diagram, we can see that we have a Lua core, which are like bits and pieces that make up the gateway, such as the router, the balancer, the admin API, and a bunch of plugins, right? So many of them come bundled, but you can also load in custom plugins of your own. But essentially, this is how all of the Lua parts of the gateway are constructed. And once you interface with the gateway via the admin API or via like your declarative config files and all that, like these are the Kong configuration file. These are the things that you're configuring, and so your interface with Kong itself as an administrator is through those Lua parts, right? And as a plugin developer is by developing Lua extensions that will be loaded as plugins into the LuaJIT VM. So once we extend that model to add WebAssembly into the picture, how's that going to look like, right? And I had another slide just to say that besides the plugins that come with Kong, you can like load additional plugins of your own. So in the end, this is like a more accurate depiction of a typical Kong installation with custom plugins. So yeah, so now let's move into talking about fitting WasmX into Kong, right? So we start with that build of the Kong core, including WasmX. But at this point, when we look at this picture, that orange module there with WasmX and the Wasm VM, which is the purple one, the bright purple one that's running inside it, that's not really connected with all of those other parts that make the gateway, right? Like, so how does it interact with all of the other parts of the execution, which are all written in Lua? So we need to make a connection with that part as well, because WasmX itself is an Nginx module. It really knows about Nginx. It doesn't know about OpenResty or LuaJIT or the like. So we actually need to add like an additional bridge into that. And so for the tech preview, well, it's pretty logical when you think about it, like how to extend the Kong gateway? Well, via Lua plugins, right? So what we really want to do here is extend the Lua gateway to make it WebAssembly enabled. right? So the way we're doing it here in the tech preview, and really there are two ways about it, right? Like you have to either extend the Kong core to have that bridging, or you have to extend it via a plugin. So for the tech preview, what we're doing, because it's the tech preview after all, and this is how like we are first approaching and proving the concept and demonstrating the concept for to you all, is by adding a Lua plugin that interfaces the Lua core with WasmX. So there, like in darker blue, I added a new plugin to the picture called Proxy-Wasm, because that is the API that is being exposed to end users. So with that Proxy-Wasm plugin, once you do that, now you can load Proxy-Wasm filters, which are essentially a new way of extending Kong. Besides extending it with Lua plugins, you should now be able to extend it with Proxy-Wasm filters, which are themselves written in any language that's supported, like any language that happens to have a Proxy-Wasm SDK, which on its turn implements the Proxy-Wasm binary interface for WebAssembly. Right, so all of those languages that I mentioned earlier would pretty much apply, right? So with that in place, now let's get even more concrete and go for the demo. And let me get my terminal on screen. Should be able to see it. And well, since everybody loves like the tense moments of, you know, praying to the demo gods and hoping that everything was fine, and people like watching you make all sorts of typos and such, I'm gonna avoid that by doing the way we actually do in real life, which is automating things so that you don't make silly mistakes. So for here, what I do have like is a small script which looks like essentially like what I would type in the demo. So so what are we doing here? So first, I'm going to get an Proxy-Wasm SDK from a third party, and just to really bring the point across that this is gateway agnostic and standard, and it adds the possibility of running third-party filters, which were not even designed for Kong. So that's what I'm going to do here. I'm just going to get one of the examples out of the Go SDK, which is a JSON validator filter. I'm going to compile it. I'm going to use the tiny Go compiler, which is a compiler originally designed for embedded systems, which is a Go compiler for embedded systems, because it generates much smaller binaries, and it has a target for WebAssembly formats. And here it targets what is called WASI, which is the WebAssembly system interface. So essentially, like when you think about like the standard C library, like, okay, I want to, we do like file operations, read sockets, read environment variables, all those sorts of basic things that you usually, any language relies on the system's libraries. Like, since we are on an abstracted sandbox environment, like this is the abstracted system interface called WASI. So this is what we're targeting when we run a Go file, when we compile a Go file into a WebAssembly module, right? So I'm just going to copy it over, put here in the Wasm folder, and then I'm gonna start a Docker container here. So if you've ran Kong, you should be familiar with all that. And then I'm gonna load in a volume, which is like just a declarative config for Kong. I'm gonna show you what's inside that declarative config file, just like a very vanilla way of configuring Kong. And I'm gonna add to the container as well that Wasm folder containing the Wasm file, which is the filter. Right, and also a bit of a spoiler here, because we're going Kong Incubator. Going to be loading this container here in order to run an instance of the gateway, which was loaded with the Wasmer WebAssembly virtual machine connected via WasmX. Right, so just going to show you guys the configuration, and then run a couple of requests here. The idea of the JSON validator, you will see in the configuration that it will try a request that should fail and another one that should pass, just so I can show you the execution going, right? And so let's run that. So we're here compiling the Wasm file now. Yeah, let's give it a couple of seconds for it. Okay, it's compiled. So now we have started the Docker container with that WASM file we just compiled loaded. So I'm just showing as a configuration here, just making like a mock bin route here. And yeah, I gave it 10 seconds, but it was not enough to describe it. But okay, it's all just like one service, one route. And then we loaded one plugin into it. Here, the Proxy-Wasm one. It supports loading multiple filters into it. We're just loading one filter right now, which is the JSON validation filter. And we're giving it a config. For this plugin in particular, the config is a JSON string. And we're saying that we have a required key, which is my key. So that is necessary for validating the request. So what happens when we first run HTTP here and try to run it without the required key? Well, we get 403 forbidden, right? Invalid payload. And then when we try again, and we do give it my key, which was the required key here in the configuration of the plugin, then it lets it pass where we're hitting mockbin's echo endpoint, when that endpoint basically echoes back what was the input, and this was the input we gave it, and once the input we gave it contained the required key that the Proxy-Wasm filter checked, well, we got a 200 OK out of it. So yeah, so you can see like the configuration is pretty simple. It's not that different from like loading any custom plugins and or configuring them. Like for the tech preview, we just do it through the Proxy-Wasm Lua plugin, and then we can load whatever Proxy-Wasm filters we want, like as long as they they match the ABI of what's currently implemented in the in the WasmX implementation of the Proxy-Wasm ABI. Right, so that's it from the demo. And well, as you saw there in the Kong/Incubator description, well, this container is now available as part of our Incubator project, where the up and coming pieces of tech that we are developing is there for you to check out and for you to give us feedback. Of course, we're looking forward to hear all the feedback you got around the feature, and of course, designs and compatibility and all that. So it continues to evolve as we are hard at work into continuing to build WasmX and to eventually get it ready to GA and get it integrated into the Kong gateway in a future release. All right. So to recap, what have we learned? WasmX, it embeds a Wasm VM that you get. For example, here in the example I just ran, it was called Wasmer, but we also support V8 and other ones. WasmX implements Proxy-Wasm, which is the interface which is what you code towards, right? Which is essentially, if we look at if we look at the code, let me improvise a bit here. So when we look at those examples, let's see the example where we just ran, like this was the code, right? Proxy-Wasm Go SDK, JSON validation. So here's like the validation of like, that's just standard Go code, and you have things like plugin context, new HTTP context. These are things from the Proxy-Wasm API. And just what I wanted to show here is like, like you import the Proxy-Wasm SDK for the language that you want to use, and then you get like all sorts of things like this. And if we were running like in Rust code, it would look a little different, a bit more native towards Rust, but you would have essentially the same functionalities. And once you do that, you're able to write code that can be compiled and run, and executed into WasmX. So in the current Kong, so to finish our recap, like for the Kong Gateway tech preview, it includes WasmX and the Proxy-Wasm plugin in there, so that you're ready to go and to play with it and run Proxy-Wasm filters. So once you enable the Proxy-Wasm plugin in Kong, you're then now able to load those Proxy-Wasm filters. So this is how all the pieces fit together in the tech preview that we currently have. So that's what I had for today. And yeah, well, I think we'll now move to questions. Let me see.
Thank you so much, Hisham. That was awesome. And we have quite some questions in the Q&A part.
Okay, I will. Okay, let me open it up and Okay, so I'll just, okay, I see 10 open questions there. Should I just go
Yeah.
then from top to bottom and
Yeah.
read them? All right. So, okay, let's see. So first one from Leandro says, okay, ProxyWasm is a standard, right? It means that the WASM plugin from Cone Gateway would work flawless if executed on Envoy. Okay, yeah, so that's a great question. And in theory, yes, but reality has more nuance than that, which is the same as happens on every like industry-wide standard with multiple implementations, as you can imagine, right? Because we've all seen like how it is with web standards, for instance, right? Like supposedly like everything should work exactly the same on every browser, but often it doesn't because of difference in specifications and difference in interpretations of the specification, or because things are underspecified. Proxy-Wasm itself is a standard that is evolving over time. Some of the things are not fully fleshed out in the documents, and we've done a bit of guessing here and there on like what should our implementation do in terms of what makes sense, what matches the other existing implementations and all that. So the intention, yes, is for it to be compatible. And I think we should all work together as an industry to make sure that the specification, the documentation of the specification evolves so that the implementations match as well, right? So, so in theory, yes. In practice, we'll see. But I've just shown you an example of that already working, and yeah. So we expect to get this, and like any rough edges that appear like smooth out over time. So let me see what else here. Like Edmonds, and I guess you're talking in the context of the whole Kong ecosystem. It's more of a comment than a question, I guess. But well, yeah, I think this does have implications for the whole Kong ecosystem, like the including the gateway, eventually mesh and connect and all of that. Yes. So Mert says, as far as I understand, any programming language code I write is converted to bytecode and run in the browser. I've been hearing about WebAssembly for years, but I haven't seen an example used. Like, why no explosion? Like, okay, moved around. Why no explosion like Node.js or Arduino for this technology? On one hand, I think it's, yeah, I've heard about it for years, but then I think what WebAssembly is trying to do is like it's a much taller order, because targeting a single language is much easier than making something that's language agnostic and targets every language and make sure that that it works for all of them. And well, and plus WebAssembly is is part of the VMs that runs in our browsers today already. But I think at one point, as it becomes more successful, it will really be sort of invisible in the context. The gateway will be a lot more noticeable because well, the administrator has to bring in the accessibility points in there. But yeah, but I think I think it's an inevitable direction, because like everybody wants multi-language support and extending like beyond just JavaScript in the browser, or beyond just a single language and a proxy, whether it's like Lua and Cone Gateway, or it was like C++ filters originally in Envoy, as it extended by adding WebAssembly and getting support for more languages. So let's see, next question that's at the top here. Are Go plugins considered a bad way to go for custom plugins? One of the earlier slides seem to suggest this. The current implementation of the Go PDK, it has some significant limitations that we're all very aware of. In terms, because of the current architecture of when you have languages which were not designed for sandboxing, like the implementations that were not designed for sandboxing, the way to get a safe execution was through the sort of like that sidecar approach that does have implications in terms of latency and things like that. and the extent of the PDK that was implemented for that. So if the current state of Go plugins solve your problem and present sufficient performance, right? There will be no reason to not to use them today. But for many of the scenarios that we see people using the gateway and reaching out for extensibility, we see that people ultimately currently they almost always go towards Lua plugins because they give the ultimate performance and they have like all of the extensibility points available. So in that sense, our current approach for Go, that what's on GA right now, like for Go PDK and such, it has significant limitations, and we see that the feedback that we get is that people most often end up gravitating towards Lua for that reason. And what we hope is that with WasmX, we should get a different avenue for extensibility. There's cross-language that does include Go, but we'll have much tighter integration. It runs as part of the Nginx binary. It has sandboxing out of the box, so that allows for a tighter integration. And it implements like a much more extensive SDK. So really what I'm saying is that like we expect looking forward, like the route for Go extensibility, like for the future, once this gets all the way to GA, is for it to go like like through WasmX instead. Let's see. We have another one from Leandro here at the top. I'm going top to bottom. I don't know if Dalia, if you're like sorting them or
No, that's fine. I'm just marking the ones you answered as answered already.
Okay.
Yeah.
Yeah, because I'm seeing the list move around. So yeah. Okay, so let's go. Another one from Leandro here. It says all Kong plugins have their own weight, and the weight is useful to create a plugin pipeline to tweak the request or response. Since we have this ProxyWasm, since we have ProxyWasm as another plugin to Google Wasm together, does that mean that the weight is fixed? Oh, okay. I think I need a clarification question. You can even answer in chat. Like, by weight, do you mean the priority? Like, because that affects like the ordering, right? Like when you say plugin pipeline. Yes, priority. Okay, thanks, Leandro. Well, that means that if you look at the way that I showed the configuration of the I'll show a different demo here, like a different demo configuration. Just because you can have multiple filters in there, and the list of filters here is the one that determines the ordering, right? So instead of, because since ProxyWasm filters do not declare like a Kong priority, right? What you have instead is that the order that you describe your chain of filters here, like it indicates the order that they will run. So if I've done this, oops, if I've done this, then that would change the order, right? And yeah. So to clarify the question, yeah, if I like to use request transform, ProxyWasm in course, yes. So the ProxyWasm plugin itself has a priority. I think it currently runs last, but then again, you would still have them, like all of them run for each phase of the request, right? Like access phase, then header filter phase, then body filter phase. So if you add filters that runs on different phases, they will all run at their correct phases, right? So probably like in your example, like horse would run first, and then like if you have a response transform, that would run at the end because it's dealing with the transformation, right? So depending on what your ProxyWasm filter does, like if it extends, some sort of like authentication and callback, that would run at the beginning, but say if you're extending like logging, that would run at the end, right? So that depends. So the order that your WASM code would run would depend more on which callbacks you implement in there. But in the context of the ProxyWasm plugin there, which is a driver, right? Yeah, it has a fixed priority. So yeah, that ended up pretty technical, but I hope the explanation makes sense. So yeah, let's see other questions. So are you going to release WasmX as open source? Well, honestly, I don't have an exact answer at this point, depending on what's going to happen as it goes to GA. But yeah, right now it's going to the incubator pipeline, and we'll see as the project evolves, what really is going to happen with it. Next one, is it a plan in the future to decommission LuaJIT in favor of WasmX? No, I like for this one, I will just give you like my very personal answer, like not speaking for the whole company, but like I think that's like extremely unlikely given the amount of stuff that we have developed on top of LuaJIT, and especially like the wealth of like custom plugins and things that like our community has built over the years, right? So I don't think it would make like any sense for that to be thrown away. So yeah, so let's see how next one, interesting one, like how do WASM plugins compare in terms of performance to the Lua plugins, right? At this stage of the project, I really like the qualification there, because well, at this stage of the project, we're not really in a position to give performance numbers because it's under development. But one comment that I think it's like super relevant in this case is that first, well, different plugins have very different performance characteristics. Like, so even for Lua plugins, right? So you will have Lua plugins that run super fast and other ones that run super slow, depending on like how they're written or what they do, right? Like some of them are just like naturally heavier than others. But what I can say is that WebAssembly gives you like yet another variable to consider on top of that, because you will be using different languages, and each of these different languages have different compilers, and these languages have different performance characteristics themselves, and the compilers that implement them also have, right? Just like if you think about it, like C is fast, right? Okay, but then there are different C compilers, and some of them generate faster code than others, right? So so you get that layer of complication as well, right? And when you say, okay, what's the difference of performance of a Lua plugin versus like a plugin running on Wasm? Okay, like I expect a Wasm plugin that's written in Rust versus one that's written in Go, depending on what it does. Like I would expect them to have different performances as well. So if you're like aiming for the ultimate performance, if you really need that, like that will be another variable to be taken into consideration. Let's see. Like, is there a market? Next question from Dennis. Like, is there a marketplace or a hub for WASM plugins or filters? Well, I think at this point, well, not at this point in time, like not coming from Kong at this point in time, but I definitely think that like eventually, as we start to develop like an ecosystem of ProxyWasm filters developed like by Kong, by the Kong community and all that, like I could very much see that happening, right? And something like that in the future. But yeah, but at this stage, is like it's too early to tell like which shape or form that will end up having, right? But yeah, but it will be nice to have. Yeah, there's a clarification there saying that was referring to Go PDK. I think I covered that. So yeah, like, so okay, Fel, there you have, Fel has a, hi Fel, there's a question there about the advantage of WasmX over the other PDK languages that Kong supports. Yeah, I think I went a bit around that in terms of like all of the various languages that are supported via Proxy-Wasm, they will talk to the same API. So it will have like a consistent support from our side, from the host side. The very fact that like third parties, like as new, like the next flavor of the month in terms of language becomes popular and decides to implement a ProxyWasm SDK, we will get support for that for that out of the box. And then again, like going back to that Go PDK discussion that I mentioned earlier, like the very fact that this is built as an Nginx module and not as a plugin server sidecar, right? That should give us, like we expect, performance advantages, like a tighter integration. So yeah, so we're excited about that as a path moving forward. Let's see another one. Okay, there's two there from Andrea that says, okay, Microsoft has a Blazor server technology. How can we integrate WasmX with it? Okay, unfortunately, I'm not familiar with Blazor. I will check it out and see how exactly does it relate. So WasmX is in itself is designed as an extensible piece of technology in terms of supporting different VMs. So if that's a WebAssembly VM from Microsoft, we currently do not support it, but we could in the future if it proves like advantageous in terms of functionality of performance or something like that. Yeah. So Dennis asked about performance. Okay, I think that's a repeat. We've already covered that one. Yeah, I think the other ones are already repeats. Like, okay, intention of removing the Lua runtime. No, like that's not like in any roadmap. And the last one was also like benchmarks, asking about performance. So yeah, that one has a little bit of a clarifier. Like, are there still like best practices, things to do and not to do? So I think it would be useful to touch on that a bit. Like once WasmX gets to GA and we get to the gateway integration, we will definitely have documentation and best practices and examples and all of that. We're at this point, it's very early. Like even the Incubator one, like it has like instructions on how to get like demos running and play with it. But once we get to GA, like we're treating documentation very seriously, and we really wanted to to get those best practices and examples and really guide you on how to make the best use of the technology, right? Those were like a lot of questions. I think it was the most questions I've ever had in a user call presentation here. So that was super exciting. And yeah, so really happy of the way this turned out. Thank you, Dalia, for setting it up.
Yeah, of course. Thank you so much for the great presentation, for answering all the questions. And thanks everyone for joining us today. We hope to see you at our next user call on December 13th, where we're going to talk about new plugins in Kong Gateway 3.1. So make sure to be there. Thanks one more time, Hisham. Thanks everyone, and see you soon. Bye.
Bye-bye. Thanks.